Everyone, and welcome back to Global Education Zone. And I know that you've probably come across the concept of geometry in previous episodes. And then geometry, we are going to be talking in this video. We are going to be talking about geometric ratios, and then I'll be giving some theorems, which I'll be proving some of them. And then most of these theorems will be based on similar triangles. So let me start from similar triangles. So similar triangles is a concept that you probably have covered in your junior secondary school and your earlier education in mathematics. So similar triangles, basically they are those triangles that they have their sides in a same ratio. So the ratio of two corresponding sides will be equal to the ratio of other two corresponding sides, ratio of other two corresponding sides, and so on and so forth. So and the ratio of and the angles of those similar triangles, they are always equal. So the corresponding angles are equal and the corresponding sides are in the same ratio. So that's what similar triangles are. So then let's use that knowledge and use them to prove some of these theorems as we move on. So the first theorem we'll be talking about here, and this chapter, this episode is on geometric ratios. So the first theorem we'll be dealing with here is the theorem of, which states that if three or more lines cut equal intercepts on a transversal, if three or more parallel lines cut equal intercepts on the transversal, then those three or more parallel lines, they will cut equal intercepts on every other transversal. So what this means is that let me prove this theorem. So imagine we have three parallel lines. So imagine we have a transversal line here, and then we have three parallel lines here. Three parallel lines. If these lines are parallel to each other, so what this theorem is saying that is that if these three parallel lines cut equal intercepts, so that means if they cut intercept, if this ABC and AB is equal to AC, that means this is equal to this. So that means these three parallel lines will cut equal intercept on any other transversal. So that's what it means. So if we have another transversal here, they will cut equal intercept. We are trying to show that this, if this is xy and this is z, if that means xy must be equal to yz. So let's prove that. So imagine we draw an imaginary parallel line from this point x to this parallel to AB. Let's draw a line xe, and then let's draw a line yf parallel to this one, yf. Now we can show that this one, if this is parallel to this one, this is parallel to this line, right? And this is also parallel to this line. So we can show that first of all, this is a parallelogram. This ABEX is a parallelogram. So that means this side AB must be equals to EX. So side AB will be equals to, automatically will be equals to side XE. And then in the second one, which is also a parallelogram, the side BC must be equals to side YF. So that's the first thing we are going to show. Then next we are going to show that assuming this is angle G. So if this is angle G, that means this will also be angle G, because these are corresponding angles. So and then if this is angle H, this will also be angle H, because these are corresponding angles. So from this fact we can show that these two triangles here will be similar. Why? Because for similar triangles you have not even similar, they will be congruent, because we have two angles and a side. So we have two angles and an included side. So that's ASA. So that is one of the conditions for congruency. So one of the conditions for congruency is that two angles and a side must be equal. So you can see that these two angles, we have angle G and angle H equal to angle G and angle H, and then we have angle XE equals to angle YF. The reason is that because AB is equal to BC, so that means XE must be equals to YF. So that means if triangle XEY is similar to triangle, is congruent rather to YFZ, that means this corresponding the corresponding length of the side must also be equal. So that means this XE must be equals to YF, and also XY must be equals to YZ. So that means line XY, length XY will be equals to length YZ. That is the proof that because these parallel lines cut equal intercept here, they have also cut equal intercept here. So the proof of that is that this line XY is equals to line YZ. That's what we've just shown now. So that is the first theorem we've been proving here. Then we also have Next, in this topic on geometric ratio, we'll talk about how to proportionally divide a straight line segment into a number of parts. So if you've not checked out my video, I also teach technical drawing, and I have done some videos in practically how to divide a line into segments. You can check out that video too, so to gain more knowledge on that. But then majorly, if you have a line AB from A to B, so basically what you need to do is you just draw a line at an angle to that line and divide that line into the number of segments you want. So if you want to divide AB into 6 segments, you divide that angled line in 6 segments, then you connect the ends of the 2 lines together, and you begin to draw parallel lines to the lines. So you are already dividing the line into a number of segments. So that is simply the method. But now let's talk about another theorem. Let me prove another theorem here. And this next theorem states that a line drawn parallel to one side of a triangle divides the other 2 sides in the same ratio. So what you are trying to say here is that if we draw a line, if this is a triangle here, if we have a triangle ABC, that means we are trying to say that if line XY is drawn parallel to one side of the triangle, so if line XY is drawn parallel to line BC, that means it will divide angle, it will divide this AB and AC in the same ratio. That means AX over BX must be equals to AY over CY. So this is what we are trying to prove here. So it's actually, let's see how we can prove it. So we can see that if we draw an imaginary line here, imaginary diagonal from this trapezoid of the trapezoid. So we have we have drawn an imaginary line. So we can see that for this on this base, there are 2 triangles on this base. So we can see that they have the same height, because from here to here, they all share the same base, and this will be their apex, right? So since they both have the same apex, that means they have the same height. From the base to the apex is the height. So that means this triangle AXY and triangle BXY have the same height. So we can also say that, we can also simply say that AX over BX, this AX over BX is equivalent to AX over BX is equals to triangle AXY all over triangle BXY. So the reason is that, from what I explained earlier, this triangle AXY and triangle BXY, they share the same, they are both on the same base, and then though they are not superposed, but they are on the same base side by side. But the reason why they have the same height is that they have the same apex. So from the base to the apex is measures at the height. So that means they automatically have the same height. So that means this statement also will be true. But at the same time, we also have for this AY, we also have this for this AY, we have this triangle AXY and triangle CXY. So that means AY over CY equals triangle AXY over triangle CXY. That's what is equivalent to, and the reason is still the same thing, because this triangle AXY and triangle CXY, they are both sitting on the same baseline, and they have the same apex, so they will have the same height. So because of that, that means this statement is valid. But you can see that next, let's connect these 2 statements together. This triangle BXY and triangle CXY. Sorry. Yes, triangle BXY and triangle CY, triangle BXC and triangle CYB, they must be equal, because they are triangles on the same base. So triangle BXY, yes, let's make use of triangle BXY. So triangle BXY and triangle CXY, BXY is equivalent to triangle CXY. And the reason is that these are triangles on the same base XY. So BXY and CXY, they will be equal to each other. So that means instead of, we can simply replace BXY with CXY. So that means AXY over BXY will be equal to AXY over CXY. So because triangle AXY XY over triangle BXY will be equals to triangle AXY over triangle CXY. The reason for that is that triangle BXY is equivalent to triangle CXY. They are both similar. That means you can simply say that that means from what we can gather here, that means AX over BX will be equals to AY over CY. So that is simply the proof for that theorem. So this theorem, it is used to show that when you divide when you draw a line parallel to any line of a triangle, you are dividing the other two sides by the same ratio. That's simply what it means. Then we also have the midpoint theorem, which says that the line joining the midpoint of two sides of a triangle is parallel to the third side and half of it. So and then last we also have the bisector of an angle in a triangle divides the opposite side in the ratio of the sides containing the angle. These are simple theorems that they are not very difficult to grasp. So basically, in summary, let's talk about what have we talked about in this video. We've talked about similar triangles, and we said in similar triangles all the angles are equal and the corresponding sides are in the same ratio. Then we also said we proved that if three parallel lines intersect a transversal and cut off intercept in equal intercept, then they will cut off equal intercept in any other transversal. So we also showed that a line drawn parallel to one side of a triangle divides the other two sides in the same ratio. And then we said the midpoint theorem is a line joining the midpoints of two sides of a triangle, and it is parallel to the third side and equals to half of it. Then we have the bisector of an angle in a triangle divides the opposite side in the ratio of the side containing the angle. So what that means is that when you bisect an angle in a triangle, let's bisect this top angle. So these two sides, and we have the side A, the side of length A and B, and it divides side C into the ratio D and E. So that means what this means is that AC, that means this the ratio of this D over E will be equal to what? A over B. So you can use this knowledge to look for the length of any missing one in this equation. So this when you bisect this top angle, it divides this bottom side into the ratio of the two sides containing the top angle. So that's simply what it means. Then we'll talk about similar triangles. So similar triangles basically is what this episode is all about. So thank you for watching, and see you next episode.